Hi, and welcome to a brand new video. Today we're going to be tackling this problem on the screen where you're given a tree and you need to find the lowest node that has basically the lowest common ancestor. So as you can see here, if we have 2 and 8, what we're going to want to do is we see here that no, 2 is in the left branch, 8 is in the right branch, so the lowest common ancestor is 6 here. So, what you're going to want to do is that we have, I guess, two cases. So we have the fact that they're both in left, or you could have them both in a right at any given node. Or you can have them in separate at any given node. So if they're separate, that is the lowest common ancestor because if you go either way, then you won't have the other one. However, if you're in one of these two conditions, you can go one node down in that direction. So we're going to be using that strategy in order to solve this question here. So what I'm going to do is I'm just going to create a private boolean contains in which you get a tree node, and you also get the tree node of what you're looking for. And you say that if node is equal to null, obviously you return false. If node.val is equal to looking.val, return true. And also don't forget to import tree node. From tree node. Well, I want to import this one here, but since Eclipse kind of imports it for us, we don't need it here. And then, otherwise, we just return contains node.left looking or contains node.right looking. And what I did is that I take a node and I just see whether it or any of its children contains the value at what we're looking for. And this just looks at the current node and just iterates through the branch. And that will be important for this step to see whether this node is in the left, right, or whether it's, well, if it's the node we're looking at, that isn't possible in this scenario, but it will be helpful to see whether or not it's in the left branch or the right branch. So then we need to actually create one more method, which is going to be the recursive one. So we're going to do private tree node recursive, and we're just going to take in one parameter, which is the node, because that's the only one that's changing. We can set these two as a class variable, and that will just reduce the storage memory that we take up, because we're never changing the value of P and Q. So now, what do we do inside this recursive function? Well, we say that if contains node.left, if it contains P and contains node.left contains Q, then we have to return what recursive of node.left returns. Likewise, if we have it on the right branch, both of them are on the right branch, you have to return what the right branch will return. But otherwise, if they're on different branches, we can safely just return the node. And then the answer will just consist of returning recursive of root. So what we did here is that we created a method that sees whether or not the node that we're looking at is in that branch. So if it's a child of this node here. And if it is, we can actually use that in our recursive function. So if both of them are on the left one, then we move down into the left, one more node in the left side. If it's on both right, we move one down in the right side. And if they're separate, then the current node that we're looking at is the one that's the answer, right? Because if we go in either direction, we won't see the other node. So this is the solution to the lowest common ancestor problem, and I hope it helps. See you in the next video. Bye.